All right, greetings, scholars. We're continuing our exploration of Chapter 3 on functions, and here we're going to be working on Section 3.6, absolute value functions. So this does kind of serve as a bonus lecture. I don't think you're directly responsible for it, but I'm just doing this for completeness. So again, we're working on Section 3.6, absolute value functions. So some learning objectives here, and it's a fairly short section as well. Learning objectives. In this section, you will graph an absolute value function and solve an absolute value equation. So the absolute value function, f of x equals the absolute value of x, is going to be x. The output is going to be x whenever x is positive, or it's going to be negative x whenever x is negative. In layman's terms, absolute value is a positive distance away from zero, right? A number is, right? So whenever you take the absolute value of a positive number, it's just whatever that number is. When we take the absolute value of a negative number, it's going to be the opposite, or the negative of that negative, right? So that way, absolute value always outputs a non-negative number. Okay. So here's an example on using absolute value to determine resistance. Electrical parts such as resistors and capacitors come with specified values of their operating parameters: resistance, capacitance, etc. However, due to impression in manufacturing, the actual values of these parameters vary somewhat from piece to piece, even when they are supposed to be the same. The best that manufacturers can do is try to guarantee that the variations will stay within a specified range, often plus or minus 1%, 5%, or 10%. Suppose that we have a resistor rated at 680 ohms plus or minus 5%. Use the absolute value function to express the range of possible values of the actual resistance. Let me think about it. So if the absolute value of x, what's a piecewise? Here, I'm going to just use this right here. So we can find that 5% of the 680 ohms is 34. Let me see. So the absolute value of the difference between the actual and the nominal resistance should not exceed, let me see. What am I missing here? There's still... Okay. So whatever your resistance is, it needs to be plus or minus 5% of 680. Suppose we have a resistor, 680 ohms. Okay, so 5% of 680, 10% would be 68. So then half of that would be what, 34? So the difference between the actual output and the 680 needs to be plus or minus 5%. Let me see, what's another way? Well, if we think about our ohms minus what it's supposed to be, it needs to be within plus or minus 5%. So before I do that, this needs to be less than, like if you said what, plus 5%, we said 10% was 68. So an additional 5% would be what? 34. So it has to be between plus or minus 34 ohms. And then, so from there, we can just say this. Yeah, sorry that one's so choppy. Let me see. I think, yeah, because again, it's supposed to be rated at 680 ohms, right? So whatever resistance the actual output is, it needs to be within a certain range, right? Within plus or minus 5%. So 5% is 680. Again, 10% was 68. Then half of that was 34. I think this is okay. You know, so let's try another one. I know that one's a bit choppy. I'm not used to seeing it articulated that way. Oh, and equal to, right here. Okay, let's just try another one. Write an equation for the function graph. Okay, so we can use transformations from college algebra 1 to graph this, right? So like if we let our parent function be absolute value of x, all right? So like if we start with the absolute value of x, and you can kind of track the vertex, right? So the vertex starts here. It went what, right 3, and then it went down 2, right? And it looks like it's a little bit distorted as well. It looks like the y values were doubled. Okay, so it looks like there are 3 manipulations at play. We went right 3, down 2, and caused a vertical stretch by a factor of 2. Okay, so to capture the going to the right by 3, I think we subtract 3 on the inside. So we're going to do f of x minus 3 to give us the absolute value of x minus 3. Okay, that should move it to the right by 3. Then if we want to go down by 2, we're going to say f of x minus 3, and then minus 2 on the outside of our base function. So that's going to be the absolute value of x minus 3, and then minus 2. We probably should have done this sooner, but to capture that vertical stretch, we're multiplying the y values by 2. So that's going to be 2 times f of x minus 3, and then a minus 2 like this, and it should be 2 times the absolute value of x minus 3 minus 2. So we'll just call this g of x for whatever the one they have. It should be 2 times the absolute value of x minus 3 and then minus 2. Now, suppose we get this result, right? And, you know, we want to check to make sure that it works, right? Okay. So, for instance, when x is 3, we should get a result of negative 2. And we do, right? If you let x be 3, this term goes to 0, and we're only left with negative 2. When x is 2, I'm just choosing a few test points to make sure that they work. When x is 2, the corresponding y should be 0. So then 2 minus 3 is what, negative 1. Absolute value of negative 1 is 1. So then 2 minus 2 is 0. Right? So you can choose a few more test points. But I use transformations of functions from college algebra 1 to do this. I think that's, or I think it's from something we talked about earlier. I don't think in this system is college algebra 1, but it's transformation of functions. And I think we did talk about that. I'm trying to think of another way. Let's see the way the text did it. Yeah, it looks like they use transformations as well. Yeah, they did the same thing. Okay. So do the graph of absolute values always intersect the vertical axis or the horizontal axis? So absolute value functions is just a v, and usually we distort it. Either it might be open up and down, or it might open upward, or it might open downward. The vertical axis, it should always cross the vertical axis and not necessarily the horizontal. Like if we took the absolute value and moved it up, then it doesn't cross the horizontal, but it should always cross the vertical, but not necessarily the horizontal. It does always intersect the vertical, but it does not always intersect the horizontal. Okay, so solutions to absolute value equations. For real numbers a and b, an equation of the form absolute value of a equals b, where b is positive, we'll have the solutions a equals b or a equals negative b. If b is negative, then the absolute value of a equals b has no solution, right? Because absolute value is always going to give us a non-negative. So given the formula for an absolute value function, find the horizontal intercepts of the graph, isolate the absolute value term. Use the absolute value of a equals b to write a equals b or negative a equals b, assuming that b is positive and then solve for x. Okay. So for this function, find the values of x such that f of x equals 0. Okay. So if we're going to say f of x equals 0, that means we're going to have 4x plus 1, the absolute value, minus 7, that equals, we're going to set that equal to 0. Okay. So if we wanted to solve this absolute value equation, first thing is we want to isolate the absolute value. So first we're going to add 7 to both sides. Okay, I'm just going to kind of write the results. So then the 7 is going to be over here, 1 plus 4x, and it still has the absolute value. Okay, so let me think. Let me just make sure. Yeah, that should be fine. Yeah. Okay. So then from here, you know, we kind of split it. So we'll have 4x plus 1 equals 7. Let me just think. Yeah, I think this is okay what I'm doing. So, or 4x plus 1 equals negative 7. Or flip. Yeah, I think this is fine. All right. Okay. So then we just solve. So again, let me put in blue. The thing that we have to tackle on is mainly this guy. Okay. So then if we solve each of these, from the first one, subtract 1 on both sides, we get 4x equals 6. Divide both sides by 4. X equals 3 over 2. Or if we subtract 1 on both sides, negative 8. Divide both sides by 4. X equals negative 2. Okay. So then we want to check these in the original to make sure that they work. We want to make sure that when we plug these into the original, they should give us 0. So we'll do this over to the side. So then if we evaluate f of 3/2, that should be 4 times 3/2 plus 1, absolute value, minus 7. So then 4 divided by 2 is 2, times 3 is a 6. So that's going to be 6 plus 1, absolute value, minus 7. So then that doesn't, 6 plus 1 is 7, absolute value of 7 is 7. 7 minus 7 is indeed 0. So that one checks out. And then we want to evaluate f of negative 2. It's going to be 4 times negative 2 plus 1. The absolute value of that quantity, minus 7. 4 times negative 2 is what? Negative 8. So we have negative 8 plus 1, minus 7. So then that's the absolute value of negative 7 minus 7. So then 7 minus 7 is 0. So that checks out as well. Okay. So then we can be confident in these results. Okay. So we got 3/2 and negative 2. Should we expect two answers when, should we always expect two answers when solving the absolute value of a equals b? Not necessarily. All right. Like if b were 0, then I think we would expect one result, right, instead of 2. We may find 1, 2, or even no answers. For example, there's no solution to the one that's shown. All right. Okay. All right. So that was our bonus lecture. I know we kind of stumbled a little bit initially, but we got through it. So with that, we're going to go ahead and end the session here, and I'll be loading the sections for this week in just a moment. All right. And from one beautiful mind to another, enjoy the rest of your day. Take care. Peace.